Okay, let's talk about some limit examples. So, getting the limit from a graph. Remember that the idea of a limit is what a function is approaching, not exactly what the value actually is. So, if we read this question, it says the graph, or this problem, the graph of the function f is displayed below. What is the limit of f of x as x approaches 8? So, as we are getting closer and closer to 8, what is our, so from both sides, as we're getting closer and closer to 8, what is our function getting closer and closer to? That's what a limit is. And it looks like the answer would be 6. So here I would say the answer is 6. Because the function is getting closer and closer to 6 for the y value as the x value is approaching 8. What if we talked about the one-sided limit? The limit, let me draw this. The limit as x approaches 3 from the left side. If I had a plus, that would be from the right side, but let's say from the left side. So as x approaches 3, well, where are we on our function? We're here, we're here, we're here. We're approaching 4. We don't have to get to 4, but we're approaching 4. So the limit as x approaches 3 from the left of f of x would equal 4. That's something to keep in mind. Note that the two-sided limit, if I said the limit as x approaches 3 from both sides, when I don't have anything there, remember it means from both sides, of f of x, the limit of f of x as x approaches 3 from both sides it doesn't exist. Does not exist. Remember, these two limits from both sides have to agree for the limit to exist. The one-sided limits exist, but the two-sided limit does not exist because these don't agree. From the right, it goes to 1. From the left, it goes to 4, and those don't agree. Yeah, that's pretty much it for this example. I think we can move on. That was very thorough. What about this one? Here, we're not going to do this question. We're going to do something else. Instead of approaching 8, what do I want to approach? I want to say approach 3 from the left. Change my mind. The limit of f of x as x approaches 3 from the right side, what does that equal? Well, if we're going from the right side, that means we're going this way. So that means we have to go up, 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 and it looks like that's an asymptote, and this goes to infinity. So the limit doesn't exist, it's unbounded. Usually we just say positive infinity, though. This means it does not exist. But when we write the infinity, it's also describing the direction that it's going. It's unbounded, but it's going upwards to infinity. If we approached from the left side, then we would say the limit would be negative infinity. It still doesn't exist, but this is a description of how it doesn't exist. Alright, that's good for that. This is quite simple, finding a limit from a table. Remember, the limit means, like the limit as x approaches some number of a function, the limit of a function, is whatever the function approaches. So if you plug things in that get closer and closer to 1, closer and closer to 1, then the limit as x approaches 1 will be whatever the y values get closer and closer to. So without even like plugging anything in, these values, first of all, we're plugging in something that's bigger than 1, and we're getting closer and closer to 1.0000000, just 1. So we're getting closer and closer to 1. That's what this means. X is approaching 1. We're also doing it from the right side because x is approaching from bigger and bigger bigger values to closer to 1. And our y values are approaching 0.5, right? 0.499999999 it's approaching 5. So there's that. Well, actually, it's asking, I think this problem's asking, plug in 1.0001. We would plug that in, to a calculator. Plug that in there, see what we get out. That's what we'd have to type in there but the limit is going to 0.5. I guess I could type, I'll do that. I'll put it in the calculator and I'll show you. So this part of the function, when I plug in 1.0001, I get 10,000 period, undo, 0.499991645, whatever. I'm just writing it down so I can use it later on. Minus 1 over x minus 1. Now I'll plug that in. Except for instead of x, remember I'm plugging in, I'm plugging in 1.0001. And that part, so minus, that part gives me 10,000. So really, it's 10,000 and change minus 10,000. That just gets rid of that stuff. So there I would put well, and it says to round to 1, 2, 3, 4, 5, 6 decimal places. So I'll round to 6 decimal places. 1, 2, 3, 4, 5, 6. So it's 0.49999. It's like a Nazi saying now, or a German. Let's not be racist. 2. Is that racist? I think it is. Yeah, there you go. That's what you type in there. It's just that easy. You plug it in. I think one more example for this video, and I'll make it part 2. So here we're supposed to evaluate the limit using algebraic methods. What does that mean? Well, first, let me write down some stuff. First, that means try direct substitution and see what that gives you. So that's what I'm going to do. Well, if that doesn't work, if you get indeterminate forms, like this, you have to do a trick. You have to do some other kinds of tricks. So if you get an indeterminate form, you're going to try some kind of trick. And I'll probably talk about the tricks in the next video. Yeah, okay. So let's see. If we plug in 1, what do we get? We get 1 squared is 1, minus 4 times 1 is 4. So 1 minus 4 on the top, that would be negative 3. And then on the bottom, we get 1 squared is 1, plus 2, plus 1. That would be 3, 4. So the answer here, the limit as x approaches 1 of this function is negative 3/4. So that's how you do that. We didn't have to do any tricks, but that'll come up in the next video, I think.